so in this video, we're going to be talking about solving systems of rational equations, okay? Now, before we get into any of those problems, I just want to do like kind of a warm-up problem where we are solving this equation. So we have an equation, so we're going to have some value for x. Now, before I go in and I find what x is, let me write my excluded values. What are the excluded values? And these are the values. Basically, the excluded values are the values that x cannot be. And in this case, it cannot be that value because then it would make the denominator 0. Now, the denominator being 0 would come from, if I were to factor this, it would be x minus 4 times x minus 2. And the denominator being 0 would come from if x was 4 or if x was 2. So the excluded values would be 4 and 2. Now, we also have some other denominators here, but this is just 4 as well, and x cannot be 2 here either. So the two excluded values are just 4 and 2. Now, when I'm solving for these rational equations, or equations with rational expressions, basically the idea is that you want to get all of the denominators to be the same, right? As long as all of the denominators are the same, then you can technically multiply by that value on the left and the right, and it would cancel it out. So for example, if I had 1/2 plus x over 2 equals 4 over 2, well, that's silly, that's just 2, but let's leave it like that. Then I could multiply the left side by 2 and the right side by 2, and that would cancel out all of the 2's because you would distribute that to all of the terms. So you'd get 1 plus x equals 4. So the idea is you get all of the denominators to be the same, and then they cancel. So here, we have the factor of x minus 4, but we're missing the factor of x minus 2. So I'm going to multiply the top and the bottom of this fraction by x minus 2. For this fraction, we have the factor x minus 2, and we're missing the factor x minus 4. So I'm going to multiply the top and the bottom of this fraction by x minus 4. So essentially, we have 1 times x minus 2 over x minus 2 times x minus 4 plus x times x minus 4, which would be x squared minus 4x, all over x minus 2 times x minus 4. And over here we have 2 over x minus 4 times x minus 2. So you could see now that all of the denominators are all the same. For this fraction, those two multiply together. For this fraction, same thing, and for this fraction, same thing. So essentially, if I multiply both sides of the equation by the x minus 4 times x minus 2, it'll cancel it out. So again, that would distribute to both, and that'll cancel out the denominators. So I really end up with x minus 2 plus x squared minus 4x equal to 2. So now let's bring over 2 by subtracting it. And we can combine like terms. X squared, of course, would just be x squared. 1x minus 4x is negative 3x. Negative 2 minus 2 is negative 4. And then to solve for this one, I will now use the method of factoring. So multiplies to negative 4 and adds to negative 3 would be negative 4 and 1. So this will factor into x minus 4 times x plus 1. So my two solutions, x equals 4 and x equals negative 1. Now from here, I want to go back and just take note of my excluded values were 4 and 2. So this solution is actually an extraneous solution. The only valid solution here would be negative 1. So our solution is x equals negative 1. 4, again, is not a valid solution. It's an extraneous solution because it is an excluded value. It would make this denominator here 0, which would not be possible. All right. So when solving systems of rational equations, right, you just have two different rational functions, and you're trying to figure out where do those two functions meet. Well, if you're trying to figure out where they meet, right, where f of x equals g of x, really you're just taking this y value and putting it into and replacing the y value of the other one. So saying f of x equals g of x is setting the two equations basically equal to each other. So 3 over 2x minus 5 equals 2 over 2x plus 3. And then now I go in and I solve for this. Now, when I'm solving for this one, I am going to do cross multiplication because I just have one fraction equal to one fraction. So I could use the proportions in this case. So I'm going to do 2 times 2x minus 5 equal to 3 times 2x plus 3. So 2 times 2x minus 5 would give me 4x minus 10. And 3 times 2x plus 3 would give me 6x plus 9. Now I can go in and solve, subtract 4x to bring the x's to the right-hand side, and subtract 9 to bring the constant to the left-hand side. So we get negative 19 equals 2x, and then divide 2 on both sides. So our solution, x equals negative 19 over 2. Now again, you have to be careful what were our excluded values, where the denominators cannot be 0, right? So 2x minus 5 cannot equal 0, which would mean that x cannot equal 5 over 2. And 2x plus 3 cannot equal 0. So that means that x could not equal negative 3 over 2. So our two extraneous solutions would be 5 over 2 and negative 3 over 2. Negative 19 over 2 is neither of those, so this is a good and valid solution. All right. Let's look at number 1, and then you can try one on your own. So on number 1, you are doing the same thing. Now, in this case, it's a little different because look at this question for the one that we just did, actually. It asks you for what value of x. So it only asks you for the x value, right? Whenever I have a system of equations, let's say I had a system of a linear, some line, with a quadratic, some parabola. The solution is the intersection point, right? So it's whatever point, x and y coordinate, is the point that the two meet, right? So we found the x value here only. We did not find the y value for the coordinate point. And the reason for that was that they just asked us for the x value. In this case, they're asking us for the point. So after we find the x value, we're going to have to plug x in to find the output that matches that so that we can complete the ordered pair, x and y. But the general idea is the same. You were trying to figure out where f and g intersect, so I'm going to set f of x equal to g of x. So in other words, 10 over x plus 4 equal to x plus 1 over x. Now again, this is just one equation equal to one fraction, equal to one fraction. So I could use the method of cross multiplication. So 10 times x equals x plus 4 times x plus 1. Now be careful when you're multiplying. 10 times x, of course, is just easy. 10 times x, 10x. But when you're multiplying x plus 4 times x plus 1, you actually need to multiply both of the terms of x plus 4 with both of the terms of x plus 1, right? You can't just multiply x times x and then 4 times 1. So I need to multiply x times x, which is x squared, x times 1, which is positive x, 4 times x, which is 4x, and 4 times 1, which is positive 4. Bringing down the left side, I'm going to bring down 10x. And now this is going to be a quadratic because I do have a power of 2. And I'm going to subtract 10x to bring that to the right-hand side. Okay, so I have 0 equals x squared. and 1x plus 4x is 5x, minus 10x would be negative 5x. And of course, 4 is just 4. All right, now this is a quadratic. I'm going to try to solve by using the method of factoring. And the coefficient here is 1, so two numbers that multiply to 4 and add to negative 5 would be negative 4 and negative 1. So this will factor into x minus 4 times x minus 1. Oopsie. X minus 1. So our two solutions would be x equals 4 and x equals 1. Again, anytime you have fractions with variables in the denominator, you want to look at the denominator. Are there any extraneous solutions? Okay. So you always want to make sure that you don't have any extraneous solutions, right? So let's take a look at our excluded values. Our excluded values, x cannot be negative 4 and x cannot be 0. So neither one of these are one of those. So we don't have extraneous solutions. 4 and 1 are both valid solutions. So there's 2 points of intersection here. At x is 4 and at x is 1. Now they want us to give the points, so the ordered pair, the x value with the y value. So I'm going to go ahead and plug x into the function to find the output. Now it doesn't matter which function you use because it's the point that both functions share. So if I put in that x value into either one of the functions, I should get the same thing. So that's why it doesn't matter which one you put it into. So let's go ahead and use f of x for the first one. So f of 4 would be 10 over 4 plus 4, which is 8. Well, 10 over 4 would simplify to 5, or 10 over 8 would simplify to 5 over 4. So the output, the y value for this point is 5/4. So that is one of my answers. Then I also have another point of intersection at x equals 1. Let's just use g in this case, just so you could see it doesn't matter which one you use. G of 1 would be 1 plus 1 over 1, right? You're plugging in 1 in for x here. So 1 plus 1 is 2. 2 over 1, of course, is 2. So the y value in this ordered pair is 2. So when x is 1, y is 2. And that's my solution. All right. So go ahead and pause the video now and try number 1, this one on the screen, on your own. Okay, so with this one, the question is, at which of the following points does the graph of f and g intersect? Select all that apply. So I'm looking for the intersection point of these two rational functions, and I'm trying to find out which of those ordered pairs meet that criteria. So again, when I'm figuring out where they intersect, I just set the two functions equal to each other. So I have x over 3x plus 2 equal to 1 over x plus 4. Now this is, again, just a proportion, so I can go ahead and multiply 3x plus 2 times 1 equal to x times x plus 4. So 3x plus 2 times 1, of course, would just be 3x plus 2. And then x times x plus 4 would be x times x squared, x times 4, 4x. And I'm going to go ahead and solve this quadratic by bringing over everything to the right-hand side. So I'm subtracting 3x and subtracting 2. That way I get 0 on the left-hand side. And so I get x squared plus 1x minus 2. And now I could use the method of factoring to solve this one. And again, for all of these so far, it has been pretty easy factoring because the coefficient is just 1. Multiplies to negative 2, adds to 1, would be 2 and 1. So this will factor into x plus 2 times x minus 1. So my two solutions are x equals negative 2 and x equals 1. So these are the two x values that these two functions will intersect at. Now, just with these two solutions, I could pretty much cancel out 3 of these options, right? Because it doesn't intersect that x is negative 1, it doesn't intersect that x is negative 1/2, and it doesn't intersect that x is 0. Now, just because it doesn't intersect at those, and it does intersect at negative 2 and at 1 for x, doesn't mean that that's the y value that matches. So we need to find the y value just to be certain that this is the point. Because it could cross at, let's say, -2, 5. It doesn't necessarily have to cross at -2, 1/2. So I need to plug in that input x to find the output y. So let's see. F of -2, and I'll just use f for both on this one, would be -2 over 3 times -2 plus 2. Actually, it would have been easier to use g, but that's okay. Actually, let's go back, because it'll be quicker to just use g. So let's use g instead. So I'm going to find g of -2. G of -2 would be -2. Actually, that's a 1 up there. Oops. Sorry, guys. So there's a 1 up here. 1 over x, which is -2 in this case, plus 4. So we have 1 over 2. So we get 1/2. So the y value that matches this x value is in fact 1/2. So this is a good solution. And then let's try g of 1. What's the output when input is 1? So this is 1 over x, in this case is 1, plus 4. 1 over 5. So the output when x is 1 is 1/5. So this one was good as well. So both of those just ended up being correct. You always want to check both order pairs because it might not be the right y value even though the x value is correct. All right, let's try one more. So go ahead and pause and hopefully you can get this one correct. All right, so consider the system of rational equations. So again, you just have two rational functions here, and they're asking which of the following statements is true, okay? So the first statement says that the graph of the functions intersect where x is -3 and at x is 6. The second statement says that they intersect just at -3. The third statement says that they intersect at 6. And the last one says that they do not intersect at all. So basically what we have to find in order to figure out which of those statements is true is figure out where do the two functions intersect. So let's do that. Where does g of x cross with h of x? Well, 36 over, and I'll just factor this denominator right from here. That would be x plus 3 times x minus 3. And that equals h of x, which is 2x over x plus 3. So let's go ahead and write our excluded values right away. X cannot be either -3 or +3. And you do want to factor that. It makes it easier to see the excluded values if you factor all of the denominators. So these are the excluded values. And now we can go ahead and cross multiply. So actually, you know what I'm going to do? Because it's in my mind right now, this is making a lot more sense. The denominators are almost already the same. So if I multiply the top and the bottom of this fraction by x minus 3, then I will have same denominators on both. So then they will cancel out if I multiply by the x plus 3 times x minus 3 on both sides. So we end up with 36 equals 2x times x is 2x squared. 2x times -3 is -6x. And then I could bring over 36 by subtracting 36 on both sides. So I end up with 0 equals 2x squared minus 6x minus 36. I could factor out a 2. That way it makes factoring easier. X squared minus 3x minus 18. And now my coefficient is just 1, so factoring multiplies to -18, adds to -3, would be -6 and +3. So this will factor into 2 times x minus 6 times x plus 3. So I have two solutions right now, 2 points of intersection at x equals 6 and at x equals -3. However, if we look back at our extraneous solutions, or at our excluded values, excuse me, we see that -3 is not possible. So this gets thrown out. It does not actually cross at -3. Why? Because that cannot be possible for h of x. H of x will have a missing piece, which we'll talk about later on, at -3. So that x value of -3 is not possible. And so then that intersection could not be possible because that's not a possible point for h of x. So the solution here is C. That is the correct answer. It crosses at x equals 6 only. All right. So I hope that was helpful, and I'll see you guys in the next video.